Okay, so in a previous video we started to look at powers, otherwise known as indices, and we looked at the power of 2, or square numbers. We're going to extend that now and look at some higher powers, some higher indices, and just have a look at exactly what that means. So if we go back initially, just as a recap, if we think about 4 to the power of 2, that's our index, our power. 4 to the power of 2, which we would say is 4 squared, means just the number 4 times by itself, which equals 4 times 4, 16. Okay, so there's a square number. Supposing, though, we were to now increase the power, if we were to look at, let's say, 4 to the power of 3. What does that mean? It means 4 times by 4 times by 4. So it's the number times by itself again. We're looking at a power of 3. So 4 times 4 we know is 16. So we are looking now at 16 times by 4, which equals 64. 4 cubed. And we can go on, we can increase that power further. We can increase that power to, let's say, 4 to the power of 4. All that means is 4 times by 4 times by 4 times by 4 again. 4 to the power of 4. And then we've just got a multiplication sum to do. We just have to work that out. 4 times 4, hang on, we've done that one already. It's 16. Times by 4 again, we've done that one already, look, 64. So now we're just multiplying that 64 times by 4. Okay, so you might want to use a grid method for this. You could split that up to make that a little bit easier. So we're going to say it's 4 times by 64. 4 times by 60 is 240. 4 times 4 is 16. Add our numbers up. 256, which of course is what we were working out before, was 4 to the power of 4. So what we've done there is we've worked it out. What you might be asked to, you'd probably see in an exam, the term would be evaluate. You'd be given something like 4 to the 4, 4 to the 3, and you'd be asked to evaluate that number. And all that means is work it out, just what I've done here. Let's look at a couple of examples like the ones you are likely to see in an exam, where you would take this basic knowledge, this basic process, and you combine it. You've got two numbers here. So we've got 2 to the power of 3, which is known as 2 cubed, 2 to the power of 3, multiplied by 3 squared. Okay? There's no magic really. We just need to what's called expand these numbers to work out what each of these two terms is. So 2 to the power of 3, that's 2, times by 2, times by 2. 2 times 2 is 4, times by 2 is 8. Equals 8. What about this second bit? 3 squared. We're multiplying by 3 squared. So multiplied by 3 squared means 3 times by 3. 3 times 3 we know is 9. So actually we're coming down to 3 squared times 2 cubed times by 3 squared equals 8 times 9, which equals 72. So what I've done there is I've evaluated 2 cubed times 3 squared. You might also see this sort of sum. Evaluate 2 cubed plus 3 squared. So we've got an addition sum here instead of a multiplication, but we do it in just the same way. 2 cubed, well, we know what that is because we just worked it out. It's 2 times 2 times 2, which equals 8, plus 3 squared. We've worked that out already. 3 times 3 equals plus 9. 8 plus 9 equals 17.
Okay, Mary, so let's have a look at this one. So solve x plus 2x equals 12. So what do you think you do first?
Okay, well, I want x on its own, so I would put x equals 12 minus 2x.
Okay, so a lot of the time we want to get x by itself, but what we want to do first is get all of these x's together. So can you see anything we can do with this? Get all these together in one place.
Oh, okay, it's 3x, isn't it?
Yeah,
so
absolutely.
3x equals 12. Oh, and so x equals 4.
Brilliant, spot on, well done.